Last lecture we have seen your adder circuits, full adder and half adder. Let us see one question based on this. Write down. Implement the following functions. Implement the following functions. Implement the following functions using half adder. Using half adder. Using half adder. Please copy this. Right. Copy this. Okay. Suppose you need to make these three functions using what? Half adders. Let us see how to make this using half adders. First, let me take one half adder. So, what are the inputs? A, B, sum, A XOR B, carry, AB. Okay. Now, first take here one more input C. What is the output you get? Take one more half adder. A XOR B XOR C. First job is finished. So this is your function 1. What about the remaining 2? See here. In the question, please make like this. You can take like that also, nothing wrong, but let me take A bar B plus A B bar C. Now, if you take C common, it is A bar B plus A B bar into C. So, what is this expression indirectly? A XOR B into C. Similarly, here also, take C common, A bar plus B bar into C plus AB into C bar. What is A bar plus B bar? AB whole bar into C plus AB C bar. Now X bar Y plus XY bar. So X XOR with Y. Right. So now first function is finished. What about the second output? I'll get product of these two inputs. That is A XOR B into C. Function 2. Okay. Now take one more half adder. Okay. What are the inputs? A, B and C. So what is the output? A, B XOR with C. What is this output? Multiplication of these two, that is A, B, C. But this is what we require. So we got all the outputs required or not. Function 1, 2, 3 are available for us. So how many are? 3 half adders are required. Copy it. Okay. Listen. Next, we'll see the application of this full adder circuit, okay, in the parallel adder circuit, okay. Anyway, coming to the next one here, other than this full adder, half adder, we can have one more circuit, what we call it as a subtractor circuit. Full subtractor, half subtractor, like that we can have. Similar to adder, we can have subtractor circuit also. Next, first keep the heading. In the subtraction also we can have half subtractor, full subtractor. Okay. First let us see those full adder, half adder. Similar to that, let us see half subtractor, half full subtractor. Then we'll see the application of that. Okay. Now keep the heading half subtractor. HS, half subtractor. Half subtractor. Let us go to the basics of your subtraction first. In the addition, we have the two inputs, we have two outputs. What are the result contains? Sum and carry. Similarly, in the subtraction, what are the results we'll be having? Let me check. Let us take one decimal example. For example, I am taking 49 from 75. So 9 cannot be subtracted from 5. What we do? We take one borrow. Decimal number. Okay, this borrow 1 will become here how much? 10. 10 plus 5 is how much? 15. 15 minus 9, 6 is the answer. 1 is given as borrow. What is the left over here? 6. 6 minus 4 is? 6 minus 4 is 2. Right. This is what we do. So when we do the subtraction, here he has done the subtraction, there is no require any borrow from the other side. But here you need one borrow, that is 1 is taken as borrow here. That will become 10. That is decimal mein we have studied in the school level. Now let us see binary. In the binary, suppose I want to take 1 1 minus 0 1. 1 1 means how much? 3. 0 1 means how much? 1. 1 minus 1 is 0. 1 minus 0 is 1. No problem. 3 minus 1 is 2. Okay. For example, I have 1 0. I want to subtract 0 1. 1 0 means what? 2. 2 minus 1 is how much? 1. But now you observe. You cannot take 1 from 0. Take here one borrow. Previously 1 is taken. In the decimal it has become 10. In the binary, if you take a borrow from one position to another position, it will be multiplied by 2. Here it is decimal, it is multiplied with 10. So here it is binary. This 1 is how much here? 2. 2 minus 1 is how much? 1 is the answer. But 2 in the binary is 1 0 only. Please listen. If you take a borrow of 1, in the decimal system it becomes 10. Here it will become 2. 2 means 1 0. 1 0 means 2. Is it clear? So 2 minus 1, what is the answer? 1. 1 is given as borrow. Then what is the leftover here? 0. 0 minus 0, 0 is the answer. So 1 0, 2 minus 1, what is the answer? 1. So you got the answer or not? Now you can observe, whenever you do the subtraction, your result contains two parts. This is what we call it as difference. And we need one extra called as borrow. We need one extra what we call it as borrow, and this is what we call it as difference. Right. So in the half subtractor circuit, we'll be having the output contains two. What are they? Borrow and difference. So the input is 2 bits, A and B, and the output is also 2 bits. What is that? Borrow and difference. Let us take it as B naught. 0, 0, 0, 1, 1, 0, 1, 1. When A is 0, B is 0. 0 minus 0 is 0. No borrow is required. When A is 0, B is 1. You need to subtract 1 from 0. We are doing A minus B. 1 from 0. I cannot subtract 1 from 0. What I need to do? Here I need to bring a borrow from the higher order state. That will become 2. Then 2 minus 1. What is the answer? 1. Is it clear? To subtract 1 from 0, you need to take a borrow 1 from the higher order state. It will become 2 here. 2 minus 1 is how much? 1 is the answer. This is the borrow taken, and this is the difference. You got it. So 1 minus 0, what is the difference? 1. No borrow is required. 1 minus 1, what is the answer? 0. Difference is 0. I don't require any borrow. So this is the table for your half subtractor circuit. This is the required operation for us. So what is your D? Same as your previous case. A bar B plus A B bar, which is A XOR B, nothing similar to your sum only. What about borrow? What is borrow? 0, 1 means A bar into B. Okay. So here A, B, these two is A XOR B is the difference, and A bar B is the borrow. Okay. So that is about your difference and borrow. This is the half subtractor. It contains two inputs, A and B. It contains two outputs, difference and borrow. Okay. Please understand, if you recollect half adder, this inverter is not present, for example. It is same as half adder. So you can say only one inverter is difference between half adder and half subtractor. If this inverter is not present, it is half adder. If it is present, it is half subtractor. Okay, copy it. Right. Let us see the implementation of this half subtractor circuit using your NAND gates and NOR gates. So keep the side heading, implementation of Implementation of half subtractor using NAND gates and NOR gates. Implementation of half subtractor using NAND gates and NOR gates. Let me check with NAND. The basic part is same, because XOR gate, how many gates are required? We know 4 gates. A, B. This is A XOR B. Up to this, okay. Here, I need a carry. What is the carry? A bar, sorry. I need borrow. What is borrow? A bar into B. This is my difference. What about the borrow? See here. A, it is AB bar. It is B, AB bar. So this into this. What is this? A into AB bar whole bar, which is equal to A into A bar plus A into B bar. This one, B into A bar plus B into B bar, that is A bar B whole bar. So here you take one AND gate, then it will become A bar B, which is nothing but my borrow. So how many gates are required? 4 for this, 1 for this, minimum 5 gates are required. Okay. So now let us make it using NOR gates. So if you take A here, B here, already we know this. A XOR B. This one is A XOR B. In the previous chapter we have discussed this point. Difference. What about the borrow? Here it is A bar plus B bar, or you can write A bar into B bar. This is A, this is B. Now what is this output? This plus this whole bar. A plus A bar B bar whole bar, which is nothing but A plus B bar whole bar, which is A bar into B. So it is in this line, you can directly say it is nothing but your borrow, which you don't need extra gates. But 1, 2, 3, 4, 5. So how many gates are required here? Minimum 5 NOR gates are required. So this is how we make half subtractor using your NAND gates and NOR gates. Both the cases requires minimum 5 NAND and 5 NOR gates. Copy it. That is about your half subtractor circuit using NAND gates and NOR gates. Similar to this, let us see full subtractor. Why should we go for full subtractor? That is the first question you will be getting. Why should we go for full adder when you have half adder? In practice, half adder will add only 2 bits at a time, but we need to add 3 bits at a time. They are A, B and carry from the previous addition. So we need to go for the full adder circuit. Same here also. We need to consider 3 bits. What are those 3 bits here? We should understand first. See here. Let us take this small example. 1 minus 0, 1 is the answer. 0 minus 0, 0 is the answer. 1 minus 0, 1 is the answer. 1 minus 1, 0 is the answer. Okay, next. Here, let us take this example. 1 minus 0 is how much? 1 minus 0 is 1. 0 minus 1. No, I cannot do 0 minus 1. I will take 1 borrow. When you take borrow, it will become 2. 2 minus 1 is how much? 1. Is it clear? If you take a borrow, 1 will become 2 here. 2 minus 1 is how much? 1. Okay, in the binary, if you take a borrow, because units distance, okay, 2 power 0 to 2 power n. So whenever you take a borrow, it will become 2 in that particular position. So 2 minus 1, 1. So once 1 has given, what is the leftover here? 1 is given already as borrow. What is the leftover? 0. So 0 minus 0, how much? 0. 1 minus 1, 0. Okay. For your better understanding, so 75 minus 49 is there. 75 minus 43 is there. 5 minus 3, 2. 7 minus 4, 3. 5 minus 9 I cannot do. If you give 1, 15 minus 9, 6. 1 is given, 6. 6 minus 4, 2. You observe here. Here also I am doing 7 minus 4 only. Here also I am doing 7 minus 4 only. But my answer is 3 here, 2 here. Why that difference came? Because I have given 1 borrow here. That should be considered. So whenever we are doing the subtraction, not only the bits A and B, we should also consider what is the borrow you have given. Same applicable here. You observe here. 1 minus 0 has given me answer of 1. But here, same 1 minus 0 has not given me answer of 1. Here I got 0. Why? I have already given a borrow of 1. So whenever we are doing the subtraction, we should consider not only the bits A and B, we should consider one more extra bit, that is nothing but borrow given to the lower order bit. Is it clear? What is the borrow given? Here borrow given is 0, then this is the answer. If borrow given is 1, this is the answer. Or let us take all possibilities. For example, if you want 0 minus 0. If no borrow is given, my answer is 0. You want to do 0 minus 0. If you want to give a borrow of 1, 0 cannot give any borrow. But suppose that lower order stage is asking some borrow. Then what it will do? It will take a borrow of 1 from the higher stage. It will become 2 here. In that 2, 1 will be given to the next stage. 1 will be left. That 1 minus 0, what is the answer? 1. Is it clear? 0 minus 0, no borrow is given, 0 is the answer, no problem. 0 minus 0, if you have given a borrow of 1, that is possible only when you take a borrow of 1 because it is 0. So 1 is taken, it will become 2 here. 2 may 1 is given, 1 is the leftover, 1 minus 0, 1 is the leftover. Similarly, for 1 minus 0, no borrow is given, what is the answer? 1. If borrow is given, then what is the answer? 0. Similarly, 1 minus 1. No borrow is given, answer is 0. Borrow is given, then it will become 0. So it should take one borrow. In this case, it will become 2. 2 minus 1, it is 1. Next, lastly, 0 minus 1. Already one borrow is given. 0 cannot give borrow, so it will take borrow. It is borrow taken. No need to write. I will give it again. It is borrow taken from higher order. It is borrow given from lower order. It has taken 1. It becomes 2 here. 2 may 1 is given. 1 is left over. 1 minus 1. What is the answer? 0. These are the different possibilities we have. Let us make all these possibilities into table. Then what we get, it is called as full subtractor circuit. So here A, B and C. Here difference and borrow. Please understand here C meaning is borrow given. This is a borrow taken by for this subtraction. This is borrow taken from the higher order. This is the borrow given to the lower order. You can take ABC, A, B, B, I, B not. Representation is purely your wish. So I am taking all possibilities, all zeros to all ones. Right. Please understand the first possibility. Just now we discussed all the possibilities. I am making it in a tabular form. A0, B0. Two possibilities are there. Borrow is given is nothing. Borrow is given is 1. A0, B1. Two possibilities. A0, A1, B0. Two possibilities. A1, B1. Two possibilities. Let us see all the possibilities. So, first case, when A is 0, B is 0, borrow given is nothing. Then what is the answer? I have not given any borrow. So, 0, 0. A is 0, B is 0, borrow given is 1. Just now we discussed this. A is 0, B is 0, borrow given is 1. So, in this case, I need to take a borrow of 1. It will become 2. In this 2, 1 is given, 1 is left over. So, 1 minus 0. What is the answer? Difference is 1. How much borrow I have taken? 1 I have taken. This is to give 1 as a borrow. It should take a borrow of 1. It becomes a 2 here. 2 may 1 is given. 1 is the leftover. 1 minus 0 is 1. Now, lastly, next case. 0 minus 1. Here you are doing 0 minus 1. No borrow is given. But already you know 0 minus 1 means we should take a borrow of 1. It becomes 2. 2 minus 1 is how much? Difference is 1. Borrow we should take 1. Now see here. Same case but you have given borrow of 1. So you should take a borrow. It becomes 1. Sorry 2. 2 may 1 is given. 1 left over. 1 minus 1. 0. So no difference. But borrow is. We should take borrow of 1. Like 1 minus 0. What is the answer? 1. No borrow is required. 1 minus 0 is 1. But if you have given a borrow of 1, what is the answer? It becomes difference is 0. No borrow is required. 1 minus 1 is 0. No borrow is given. Lastly, 1 minus 1. But borrow is given. See here. You have 1. That 1 is given as borrow. Then it becomes 0. Na? So we should take a borrow of 1 here. It becomes 2. Then 2 minus 1. What is the answer? 1. This is the concept, but don't confuse. I give you easy way to remember. Instead of doing all this analysis, simple logic is like this. Blindly, 0 minus 0 is 0. 0 minus 0, 0, 0. 0 minus 0 is 0. So, 0 minus 1. What is 0 minus 1? If you want to subtract 1 from 0, I already discussed in the hop subtractor. Difference is 1, borrow is 1. Again, here also. 0 minus 1, difference 1, borrow 1, minus 0, so 1, 1. 0 minus 1, difference 1, borrow 1. So again that 1 minus 1, 0. Is it clear? 0 minus 1 is difference 1, borrow is also 1. Okay, in the hop subtractor. Now that 1 minus another 1. So what is the answer? 0. 1 minus 0. What is the answer? 1. No borrow is minus. See here. 1 minus 0 is 1. Minus 0. 1. 1 minus 0 is 1. Minus 1. 0. 1 minus 1. 0. Is it clear? 1 minus 1 minus 0. You can do sequentially like this. 1 minus 1 is 0. 0 minus 1. Same. Difference 1. Borrow 1. Okay. So that is blind way to say do it, but actual concept I have given. A and B are some bits. C is the borrow given. Then what is the difference you get? What is the borrow required? Okay. So you can remember the table directly by straight away this manner or previous method, your wish. Now what is the difference expression? D is equal to sum of the min terms 1, 2, 4, 7, which is nothing as but same as your A XOR B XOR C, nothing but same as your sum we discussed earlier. Carry is sum of the min terms 1, 2, 3, 7. Let us make a K-map. Sum of the min terms 1, 2, 3, 7. Now see here. You can make 3 pairs. Then what is the carry? This carry. A bar into what is here 1 plus this one. A bar into what is common here? This one. So B. Not carry, sorry. This is difference and this is the borrow required. Plus B into C. You compare this. A bar into C, A bar into B plus BC. You compare this with your what is carry of full adder, just for understanding. AC plus AB plus BC. You can understand sum is the same, but carry it is also same, but only difference is here it is A, but here it is A bar. Okay, that is the difference. So you can understand only one inverter difference between full adder and full subtractor. You can write the expression here also. What is this? Sigma m of 1, 2, 3, 7. 1 means 0, 0, 1. 2 means 0, 1, 0. 3 means 0, 1, 1. 7 means 1, 1, 1. So here you can take in the first and last A bar B bar plus AB into, you can take common C plus here you can take A bar B common C bar plus C. So what is this? A X nor B into C plus A bar B. C bar plus C is neglected. Or you can write this as A X nor B is nothing but A bar XOR with B into C plus AB. Nothing wrong. You compare, not carry, sorry. I'm very sorry. Bar. You can compare this expression with your carry expression. What is the carry expression? A XOR B into C plus AB. So you can understand here what is the difference between carry and borrow. Sum and difference both are same. Carry and borrow difference is here A bar, here A, here A bar, here A. That only A is replaced with A bar in the expression. Or you can say one inverter is difference between your borrow and carry. Okay. So let us see the implementation if you want. A, B, C. Okay. So A XOR with B XOR with It is your difference. What about borrow? A bar into B. A bar into C. B into C. Okay. So you can understand this part is exactly same as your full adder. Only extra here you can see is this inverter is extra added. So one extra inverter is required compared to your implementation point of view. One extra inverter is required in full subtractor compared to your full adder. That is the concept of full subtractor. Please understand the inputs A, B, C are A and B are the input. C is the borrow you have given, and D means the difference obtained, and B is borrow you need to take. Okay, borrow given to the lower order and borrow taken from the higher order. So this is the full subtractor block diagram. A, B, C. Borrow input you can also take your wish. Variables can be anything. 3 inputs and 2 outputs. Okay, copy it. Right. That is about your full subtractor circuit internal diagram. Okay. Now let us see the same full subtractor circuit using half subtractors. Full subtractor using half subtractors. So take one half subtractor. A and B are the inputs. Okay. So here what will I get? A XOR B, A bar B. Okay. Now take this and C as one input. Half subtractor. What is the output? A XOR B XOR with C. Okay. Now here this bar into this. A XOR B whole bar into C. Now take this and this, perform OR operation. So what is this? A bar B plus A XOR B whole bar is nothing but A XOR B into C. This is your difference. This is your borrow. So one full subtractor is equal to 2 half subtractors plus 1 OR gate, similar to your full adders and half adders relation. So try one part as a homework. Implement full subtractor using minimum number of NAND and NOR. Answer 9,9. 2 input. But please listen. Here, please understand, it is not a self-dual expression. So here this expression is not self-dual. So borrow expression using a NAND will be different, NOR will be different. It may be same. Okay, because it is a self-dual. Using NAND and NOR, it may the basic part difference or previous some same, but this part will change in this case. So hint is you can check your half subtractor figure, you will get some idea. Okay, you check half subtractor, NAND and NOR implementation. Use that repeatedly, you will get it easily. Okay, same figure you take 2 times. Lastly, from the carry of both, you can take one NAND gate. You can try. Okay, both the answers will be 9 and 9. Okay, both the circuits are not same in this case because it is NAND and NOR both are not same. Why? Because it is not self-dual in this expression. This is self-dual. So difference is same in both the cases, NAND and NOR. But borrow is not same. You try it. Okay, copy it. If you remember or if you check your half subtractor previously done, from that you can get a hint easily. Similar to that only. Copy that. Okay, that is about your full subtractor, half subtractor. Okay, that is about your half adder, full subtractor, half subtractor parts of your arithmetic circuits in your combinational circuits. Okay, next lecture we'll see some applications like a parallel adder circuit. Okay, and all. We'll see the application of your full adder circuits and all. Application of the arithmetic circuits and some problems in the next lecture. Thank you.